Hi everyone, welcome to the video. Today we are going to solve zigzag level order traversal. In this question we are giving a binary tree with n number of nodes and we have to return the zigzag level order traversal. Zigzag level order traversal. So we did level order traversal just few days back. In that case we traversed level by level hierarchically from root to the leaf nodes. Here also we have to do the same but in zigzag order, which means for even even levels will start from the left and from odd levels will start from the right. If you see the question, this is the first binary tree, example 1. Root 1 starts from the first. Then after we are traversing from the right direction, 3 and 2, and so is there in the output, 3 and 2. And at the end, we again start from the left, 4, 5, 6, and 7. 4, 5, 6, and 7 starts from the left side, and that is what it is there in the answer also. So every even levels, we are taking zero base indexing. Every even levels starts from the left, odd levels start from the right towards left, and then again even levels, sorry, odd, even levels start from the left to right. See example 2, even level 7 first, then odd level 7 and 9, 7 to 9 starts from right, goes towards left. So is there in the output. Again sorry, even level, and again we start from the left towards right, 8, 8 and 6. So is there in the answer, 8, 8 and 6. Then again odd level, start from the right towards left. So is there in the answer. Okay, so we'll solve this question. Let me remove this unnecessary part. Now I will use DQ in this question. We'll using if it's kind of traversal. Okay, here I stored root in the DQ and an empty list of all result. So store the result traversed array. Cool. Now I will store left as true. This will be used as a toggling point, since first we'll start from left towards right, then right towards left, and then again at next level we'll start from left towards right. So we need something as a boolean value or boolean flag to toggle, so that we understand that okay, when it is true we'll start from this direction, and when it is false we'll start from the opposite direction. Fine. Now I'll have to traverse for the entire queue while queue is there, while there are elements in the queue, and while queue is not empty. Again, an NQ, or again a DQ called NQ. This will store the next level queue elements. Next level queue elements. Okay, next level queue elements. If left, which means if left is true, we I mark left as true in the beginning, because we are taking zero by indexing, and zero, and for the zeroth, which is the zeroth level, we are taking from left towards right direction. Now while again there are elements in the queue, pop it of the element. Now, if the element has left side, add it to the next level queue. Add it to the next level queue towards the left side. If it has right also, then add it then and there. Okay. So what I did, I popped the element. Okay, and if the element has left side, add its left side to the next level queue, because after this level we'll go towards next level. And if it has right side, right child also, then add the right child true in the next level queue. If the left is not true, if the left is false, which means we are in the odd based levels or odd index levels for all the elements in the queue. pop it, and you will see the difference. Left is true in the zero base indexing. Left is true in the sorry, in the zeroth, sorry, even indexes. And in that case, we are popping the left. We are popping the left. Okay. But when the left is false, which means we are in the odd index levels, in that case, we are just popping, which means we'll pop from the right side and not from the left side. So these small details will help you optimize your solution and add it to the event. And again, if it has a right child, add it to the next level queue. If it has left child, add it to the next level queue. At the end, after we have traversed one level, we will toggle this flag. Toggle this flag. Again, Q equals to NQ, because the next level Q, after we have traversed a particular level, we'll move towards the next level, and next level NQ, which was storing the next level Q's elements. In that case, we'll traverse towards that point. Return result. Let me submit it and check the efficacy of our approach. Okay, just showing some error. Let's see what I have done. 9Q, if there's a left element, then Q. Okay, yeah. In when we, at the even levels have not appended. That is why I appended. See, I appended the odd levels, but not appended the even level elements. So we omitted just one level. Okay, I will pause the video here and we'll start again. Okay, I did a blender over here. So the odd base levels, I will have to do append left and not append. That is the issue I did. So as you can see, it did the job pretty effortlessly and in very less time. So I hope you learned a new concept and enjoyed it. And if you are curious why I did append left, then I will tell you. So what is append left? Append left, add an item to the left of left end. Otherwise, the simply append will add at the right side, and append left will add from the left end. Cool. That is why I will have to use append left over here. So I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.